Hello and welcome to this video covering the computer-aided manufacturing tools in Fusion 360. I am Jess Sullivan, a student technologist at Plymouth State University. In this video, we will cover the CAM tools, or computer-aided manufacturing tools, in Fusion 360. After loading a design into Fusion, navigate to the CAM icon. This is the environment we will use to convert our models into a set of instructions a machine can use as a toolpath. It is important to understand the different methods you have available for manufacturing. We will cover CNC, or Computer Numerical Control Milling. CNC machines are subtractive in that they remove material from existing stock with a small router. While this is the opposite process of additive 3D printers, they work in a very similar way. Instead of slicing a model into G-code for 3D printing, which is a form of numerical control code, we will process a toolpath into a derivative of G-code specific to the CNC machine we are going to use. To begin, navigate to Setup, New Setup. In all likelihood, the axes displayed will be incorrect. Take some time to ensure the Work Coordinate System, or WCS, is correct. At the very least, this means the Z-axis reflects the location you expect the router to enter. The other axes and features are dependent upon your table setup in the makerspace. It may take some fine-tuning and dry runs to be confident the other settings are correct. If you need to audit a number of routing solutions, remember to always create a new setup to avoid headache. After committing with the OK button, it's time to create a clearing algorithm. Navigate to 3D, Adaptive Clearing, and take a look through all the options. While all of these must be changed to reflect your specific project when it comes to routing, many will become clear after learning about your specific hardware. First, navigate to the Geometry pane and change the tool orientation to your Setup WCS orientation. This will ensure the router is entering from the top of your model. Now we can move to the Passes pane. While this section is specific to your machine, read each line carefully. Many of these options are self-explanatory. For instance, this guitar has a large flat surface with nice rounded edges, so I will toggle detection for both of those. Before moving to the tool pane, select a vertical edge on your model. If this length is greater than that of the router bit, you can imagine what will happen. The router itself will collide with the tallest section of your model. To avoid this temporarily, and learn about the tool window in doing so, we will make the router bit longer than the largest vertical distance. Opening the tool window, navigate to make a new mill tool. I will change the shoulder and flute length to fit my model. In practice, I encourage you to feel comfortable adding real router bits from the makerspace and designing with them in mind. Now it is time to give it a go. Note, while this is a compute-intensive process, you can select the new route to see the toolpath progress. Once your toolpath has reached 100%, let's see what you have accomplished. Hit the Simulate button and toggle Toolpath and Stock. Sit back and watch your model take shape. I hope this video was helpful, and thanks for watching.